So good morning all, can you hear me?
Yes.
Yes, sir. Okay. So for those watch from the Facebook, can you hear me also? We're going to start in 1 minute. Just wait for a moment. So I think we can start. We're waiting for your questions to come in. There are some more to come in. So good morning, everyone. So I hope you enjoy your life at home, okay, while attending the lectures. So before we start, I have a few announcements. So just take note. So the first thing is about the attendance forms. So even though the attendance, I mean the real time, the synchronous attendance is not compulsory, but you have to fill up the attendance forms every class. So whether you're going to attend or not to attend. So this is very important for as a record. And at the same time, it's also important to get some feedback from you. So I know that if you want to attend or you don't want to attend, but are the topics that you want to be discussed in the tutorial. All the tutorial will be recorded, and you can watch the tutorial from the Facebook. I already make the outline for the tutorial because tutorial is quite long, right? Usually it's about 1 to 2 hours. So I made some outline which you can follow it. Later I'm going to upload it into YouTube as well, so you can easily navigate the video. Okay. So just in case you don't know, maybe I show you quickly. Give me a second. So now you can see my screen. So later I'm going to, now actually you have everything on the Facebook. Okay, so you can find it easily. However, the Facebook, they don't have the timestamp, so it's quite difficult for you to fast forward or scroll down. Okay, for example, this one. So even though I put all the detail, it's still very difficult for you sometimes to just to drag all this time bar because sometimes it's very hard to get the right one. So that's the reason why I will also include this in the YouTube. Later I'm going to give you the link. So this is a playlist with all the tutorials. So you can find all the tutorial here. And here is a bit easy because in YouTube, you can easily come to each of these sessions. So what you need to do, you need to just click on the time, then we jump to the part that you are interested. Okay, something like this. So later I'm going to give you the link for all the tutorial recording. They are accessible from YouTube. So the one that you saw in the Facebook is the same one. So it's up to you which one you want to refer to. If you have a good connection, maybe you want to check the YouTube. If you don't have a good internet connection, you want to check the Facebook. Okay. So this one clear. So it's very important for you to fill the form. So it's for the record. At the same time, I can know what topic that you don't understand. You need more discussion. So you need more discussion in the class. So today I'm going to pick a few to discuss in today's tutorial. So there are a few things we need to discuss. So it's, remember, every week you have to fill out the form. Okay, just take you 2 minutes. Okay, not take you a lot of time. So that's all about the tutorial. Any questions so far? So for those who watch from the Facebook, you can just you can just type your comment because you can on the Facebook. I'll give you 1 minute to do that if you have any questions. So any questions about this before we move on?
No.
All right. So, okay, so the next thing is about just a reminder. So this week is a week 9. Okay, for those who want to follow the new calendar, so this is a week 9. So by now you should have submit a tutorial for the week 8. Okay, if you have any problem, just let me know. So I just go through it quickly. So I think most of you are doing okay. It's quite far ahead of schedule. I mean, according to new schedule. So now it's a week 9. So you learn about the non-parametric test. Okay, so there are a lot of the assignment you need to do for the week 9. I think about 2/3 of you already finished the week 9 tutorial. So if you have not done this yet, it's okay because this week is a week 9. So this week you need to spend time. Then for those who have complete this, you can just keep going. So you can go as far as you want to go. Okay, as fast as you want to go. Okay, so this one here. So you ask a lot of the questions that you want to learn more. So actually, most of the question is not that you don't understand. It's just that you have not learned everything yet. Maybe you are in the week 9, you confused a bit. But I think at the end of week 13, after you finish to learn all the tutorial, okay, I mean all the topics, then you will get a better picture about everything that you have learned. So basically, so you asked a lot of the question about the normality, whether you need to run the normality test or you want to run for the event test for every parametric test. Okay, so Actually, now all your topics, you learn it one by one. You don't really learn it in one go. And because I was thinking that as some of you already, I think most of you, especially from the program Aqua and also Marine Science, you have learned similar thing in your basic statistics. You also have learned the same thing in your SPSS. So I thought that maybe this course we can learn how to apply all the tests that you have learned before. But actually, I realized it actually you don't really understand the things, or you forgot the things that you have learned in the past two courses related to the statistics and analysis. So that's the reason why in this course you still spend a lot of time to learn all those basics. So you still learn test by test, one by one. Okay. So for the time being, it's enough for you to learn one by one. So for example, you learn about t-test, and after that you learn about ANOVA one by one. You don't really know the relationship between the different tests. Actually, when we want to perform the statistical test, we need to know all the tests. Then only then we learn how to choose which test we're going to use. So for those who have complete all the tutorial and also assignment, maybe you have a better idea, okay, why you learn all these things separately. Then after that, how to use all these things that you learn together. Okay. So next I'm going to discuss a bit, give you the overview. So no worry if you have not reached, for example, regression or anything yet. I just want to give you the overview for all the things that you learn in this course, okay, to give you the better idea. So this is related to the question that you asked about the different question for different tests that you have asked the question in the Google form. So first thing first, so what you learn in this course is the data analysis in general. So it's not about the t-test ANOVA. It's about the data analysis. It's about the data analysis. So it's about the data analysis. So to do the data analysis, there are many ways you can do it. So one of the way we can do it, we can use the statistical method. Okay. So this is one way to do the data analysis. Another is that there are another group which you don't involve the statistical approach. So you don't use the mean, variance, or use the distribution model. You don't use the statistical approach. It's based on some, for example, model, modeling, some mathematical calculation, okay, some ordination technique, okay, to arrange, summarize your data. So this one we do not touch, okay. So that's the reason why in some of your final project, you might use some of the analysis, but it's not the statistical analysis, it's the data analysis. Okay? They use for the ecological research. For example, you calculate, the most simple one I think is relevant to you is to calculate the diversity in test, okay? All these things. So this is, they still belong to data analysis, but this is not a statistical method, okay? It doesn't mean that for all the objective you need to use statistical method, but in most cases, if we want to make a conclusion for a population, okay, and based on the sample, then you need to use the statistical method to make the inference. Okay? If you remember the first week, what you have learned, why you need to learn statistics and why it's related to the scientific research. Okay? Sometimes you don't use statistics, you use the other data analysis. But for this course, we're not going to touch about this. We're going to learn about statistical analysis. Okay. So far, okay. So any question about this? Okay. So I think this is clear. So we will skip this one. So this is not in the in this course. So we're going to skip this. Okay. So we're going to focus on the statistical method. So for statistical method, there are different schools actually. There are different approach for the statistics. So what you have learned in this course is what we call the frequencies. So you base on the frequency. So remember you have the first thing that you learn in this course is a normal distribution, right? Correct. So you have some measurement. So maybe there's a body height, okay, in cm. Then you have the distribution. So this is a frequency. And then based on the frequency, you make the decision. You calculate the probability. So this is the frequency approach. Another approach is what we call the Bayesian approach. Okay, Bayesian. So it's a different approach. It's not rely on the distribution model or p-value. They don't use a p-value at all. So they use another way to do the inference. So for this one, you did not learn. Okay. Then another one is maybe you use a likelihood approach. Okay. Or other way. So there are still many more different statistical methods. But the most frequently used in all the research articles that you see in a biological research is this one. Okay. So this is the focus of this course. So this is what you learn in this course actually. Okay, all the frequency statistics. Okay. So far, okay, right? So we will skip this. So we're not going to touch about this in this course. So this one we're going to move away. Okay, we're not going to do this. We're not going to do this. Doesn't mean that this is more advanced or it's more difficult. It's not necessary. Okay. So we didn't learn this because until today, most of the people they still use this approach when they do statistical analysis. So when we talk about statistical analysis, okay, regardless which one, so what we're going to do, so we're going to use the statistical test to test our statistical hypothesis. Okay, and the hypothesis from the research questions. So you have been doing this so many times in your tutorial. So I think you get this one, right? So so as you have learned this course, you learn so many tests, right? So you have the parametric test, which the test involve the parameter like mean and variance, and you also have a non-parametric test. Correct? Okay. And then for each one, you have for different purpose. Okay. Then you have the test to test the one sample test. So you have one sample test, and you have two sample tests. And to test the difference, then you have the more than two sample tests. Okay. So different tests is for different purpose according to your objective. Okay. Again, for two sample tests, you have a pair sample, independent sample. And then for more than two sample tests, you have a one-way ANOVA, two-way ANOVA, okay, and so on and so forth. So this is for you to test the differences. Okay. So all this to test the differences. Okay. And in addition to that, you also have some other tests, for example, correlation. So Pearson correlation. And also the regression. So this is still from the parametric test. Parametric test. So this is all parametric test. So what you have learned. Okay, so this is all parametric test. So this is to test the question about the relationship. So this is a difference, and this is a test for the relationship. Okay. So for correlation test, it's very straightforward. So you have pair of the variables. Okay. And for regression, there are more actually. So what you have learned is a simplest one, the linear regression. Linear regression. So there are more regression, multi-step regression, multivariate regression, and so on and so forth. Okay. So this is a parametric test. And then for non-parametric test, so it's an alternative for the parametric test. Because for parametric test, we usually based on the distribution model, okay, based on the parameter, and we have to fulfill some assumptions, correct? So for non-parametric test, you also have the two sample test, okay? You have the pair and independent sample. Of course, it's the calculation and also the command in R. When you do it manually, the calculation is different. And when you use R, the command is also different. Okay, you have the pair sample, independent sample. For non-parametric test, you also have more than two sample tests. Okay. At the same time, you also have the correlation test. So these are the alternative for the parametric test, are the alternative. Okay, so this one clear. Then, then the next thing is, so this is the first thing you have to know. So this is a bigger picture. And then this is also what you learned so far. So at the same time, you have other things you need to consider, and you learn about the assumption test. So you learn about the assumption test, correct? So you need to test for normality. Okay, sometimes you need to test for linearity. You need to test for the homogeneity of variance. Okay. And at the same time, you also need to look at the data type that you use. Whether it's a scale data, ordinal data, or nominal data. Okay. So all this, okay, are those things that you need to data type that you use. Okay. Whether it's a scale. So this is everything that you learn, but it seems like everything is isolated, right? Independent for each other. So if you learn about this, you don't know this, it seems okay. 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 Or you sometimes you understand everything. Okay, from here to here you understand everything. Okay. But this one you don't understand. Okay. So if you look at cost is independent topic, then it's okay. But actually, you have to know everything. You have to know how to apply the interrelationship between each of these. So now I give you the overview, what you have learned, the bigger picture. So the next thing that I'm going to do is to arrange it, okay, in a way that when you apply this in your research or in your daily life, when you want to use it, what are the things, okay, how to use each of the things, how to use the knowledge that you learn from each of the topic, okay. Okay, right? So any questions so far? Did I miss out anything? Oh yeah, there's one more. And then you also learn some other things, right? So you learn how to write the hypothesis, okay, the statistical hypothesis. Okay, this one. At the same time, you set the criteria. So you need set the p-value as 0.05 or alpha is equal to 0.05. At the same time, you also learn how to write the conclusion, how to interpret the result. Okay. So everything is together. So next thing I'm going to show you step by step. Okay. When we do the analysis, when we use it in real life, how we're going to use it, all the things that you learn in this course. So, so the first thing first, okay, in real time. So for example, in your FYB, so you can imagine in your FYB research. So the first thing that is you have your research questions. Okay, so this one I'm not going to repeat in detail as we have done this in the first few weeks, and also you've done this repeatedly in your tutorial. So of course you have your research questions. So this is the first thing. So when you have the research question, the next thing you need to do is to set your objective. So this is a very clear objective. Okay, so you want to test the differences. You want to compare between two groups. So objective needs to be very clear. Okay, so 1, 2 actually is nothing to do with statistic, right? So far. So the third thing that you're going to do is to formulate your statistical hypothesis. So if you are going to use a statistical test, okay. So this is the next thing you need to do. So the reason to do this is because when you formulate a statistical hypothesis, then you'll be make it a bit clearer what actually you want to do. Okay, what data type do you have? So for example, for your objective, maybe you say that you want to find the relationship between between A and B. Okay, but for A, for example, the color. Okay, the relationship between the color and also the size of the flower. So in this case, it seems like the objective is make sense. Okay, and but if you want to change it to the statistical hypothesis, you cannot simply just translate your objective, okay, into the statistical hypothesis. You need to be very clear. So for example, I want to set the my objective is to test the relationship between the color and size of flower. Okay. So this is objective. Do you think this objective is makes sense? Is it meaningful somehow? Just let's look at the objective. It seems it's okay, right? So what you say you want to test a relationship, okay, between two variables, color and also size of flower. So this is what you did actually usually. So if you look into the detail, so the size you raise easy, right? So it's up to you how you're going to do this. I mean, how you're going to define the size. Okay. So you have the size is let's say B, A. Okay, then this is a relationship. So this is S. Okay. So how to formulate the statistical hypothesis? Anyone want to try? How to formulate the statistical hypothesis? How I should write it? So maybe spend about 3 minutes think about this. Okay? How do I write the statistical hypothesis? Because if you cannot write the statistical hypothesis, then actually you don't have any idea what the test that you're going to use next. Okay. Anyone want to try? How to do it? Test the relationship between the color and also the size of flower. How to test the relationship? Do you think this objective is a good objective? So what does it mean actually? What does it mean? So if you are going to conduct an experiment, so you want to test of this, you want to test this. So how are you going to design your experiment or your research?
Regression.
So maybe you can explain briefly how you're going to test to collect the data of this. What are you going to do?
Like different color have different size of flower.
Different color have different size of flower, right? So in this case, what you suggest, maybe we change the research question, correct? So just now when I formulate the research question, this is the relationship. And when you just read it in one go, it seems like, yeah, it's okay, it makes sense. But when you think it deeply, how are you going to formulate the research hypothesis and statistical hypothesis, and how are you going to conduct the experiment, then actually you realize there may be something wrong in the objective. Okay. So what you need to consider, the first thing is that you need to think about, before we go to the step 3, when you formulate your objective, you need to think about the data type. So the first thing you have to consider is your data type. So that's the reason why this is the first thing that you learn in this course. Okay. So in the objective, what is sure is that you want to test 2 variables, correct? So there are 2 variables that you measure for each of these flowers. So for each flower, you need to take 2 variables. One is the color. Another one is the size of the flower. Okay. So here is very clear. So in this case, it depends on how many flowers that you want to include in your research. So the first thing you need to consider is the data type. So what's the data type for the color? What is the data type? So maybe you go to the size first, this one. What's the data type for the size? So the data type, there are 3 types, right? The scale, nominal, and ordinal. So the data type for the size is scale data, right? Okay. So again, it's not necessary. Maybe you use a size like SSL, medium, or things like that. Okay, it depends on how you measure it. So that's the reason why it's very important to define your variable. So the size is what? The size of the flower is the diameter, let's say. Then you measure it as cm. Okay, so in this case, your size is a scale data. Okay, and how about your color? What's the data type for your color? So this is nominal, right? Okay, nominal data. You have the red color, blue color, and things like that. Okay, so if you think about this, how you can find the relationship between these 2? So it's more likely the question that you are interested actually. Yeah, you want to know, is there any association, whether the different color of the flower we have different size, or different size of the color for flower we have different color. So that's the reason why you think about the question about relationship. So this is a main, not a mistake, but main misunderstanding or misconcept that you have when you formulate research questions. It's happened a lot in your tutorial. Okay. So that's the reason why you need to always change your question if you realize it. So if your one of the variable is nominal, another one is scale, then the next thing we need to think is your variable. Okay, your variable type. So it's not data type, your variable type. So your variable, whether it's a dependent variable or independent variable. So I think you have seen this in your lecture, right? Whether your variable is a dependent or independent. Okay. If this is a dependent, it's very obvious. So the size is depend on the color. Okay, and the color is the independent. Okay. And then for independent variable, you need to check whether this is a group variable or treatment or not. Okay, whether it is a group or treatment. So if your variable is a nominal variable, it's more likely your variable group or treatment variable. Correct? You have the red color, blue color, so it's like a category. Okay, nominal is like a category data, and the size is your dependent variable. So the size is depend on the color category. Okay, so if that's the case, then maybe you need to change your questions. So you want to test not the relationship, but the differences. Okay, the differences. Is there any differences in the size of flower? Is there any differences in the size of flower according to the color or something like that? Okay. So this is a thing that you need to learn, the data type and also the variable. Okay, the type of the variables. So that's the reason why you need to explain design in detail. Okay, what are the data type and also what are the variable type. So if the relationship is more likely the variables are the dependent or independent. It depends. If you have doing the correlation or regression, then it's different. Okay. So I'm not going to discuss that now. We only discuss in this example. We're not going to go everything. So if that's the case, we change it to the differences. Okay. So now you have this. So you want to test is there any different color of the flower? They have a different size. Okay, they are different in size. So how to formulate the statistical hypothesis? Can you try to do this? So how to do this? How to write it down? Any idea? Or there are something that we still need to do? So the only thing that we are sure now is the difference, right? Okay, difference. So it's more likely your hypothesis is different between the different color, correct? Then you have the size. So the mean of the size. Okay, so this mean is for the size because only for the scale data you can calculate the mean, right? Okay, of certain color is equal to mean size of another color. Okay, another one is, sorry, the no hypothesis is the size between the different color is the same size of the flower, and alternative hypothesis is the size of the flower are different according to the color of the flower. Okay. So what is missing? Can you complete this? What is missing here? So what is missing is that you have the scale, right? You are very sure that how you're going to measure the flower. But the color here, how many color? Okay, because if this is a group, if this is your variable is a group, then you need to know how many group. You need to define it earlier, very early. How many group? How many color in this case? Okay, so let's say you have 3 color. Okay, let's say you have 3 color. Then in your objective, you have to mention 3 different colors. Okay, 3 different colors. So for example, the mean of flower size of the red color, yellow, and blue. Okay, same as this one. So you just need to do this. Okay. So is this one clear until now? Is it okay? You have any question you want to ask? So now actually a lot of you are in your final year project, right? So you're going to have a briefing soon later. Usually you need to have this, okay? You need to have this in your proposal. Need to be very clear. And this is of course related to your objective. Okay. So how many, for those who from marine science and aquaculture, how many of you already have this statistical hypothesis for your proposal? How many of you already have this? Maybe a quick hands up if you have this already. No. Hmm? Okay. So this is the things that you need to have before you decide what the statistical test you're going to use in your research. Okay. So until here it's clear, right? So what's the step number 4? What's the step number 4? What's the next step? You have your statistical ready. So usually at this stage, you're going to design an experiment. So only after this, you design experiment. You design experiment. Because now you have 3 different colors, right? So how are you going to do this? So maybe you want to select the red color. So you have the red color, yellow, and blue, right? Okay. And then for each color, you want to pick up 10 different species of plant. Okay. Okay, the 10 different species of plant with red in color. So you have the ST1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yellow, you also have, you only have 8 color, let's say. You only have 8 species. Okay, 11, 12, 13, 14, and so on. Okay, and so on and so forth. So then after that, for each plant, because you already group them into the red color category, what you're going to do is just measure the size of the flower. Okay. So the next thing is to design experiment. It's not to conduct experiment, but it's just to design experiment. So that now you know that okay, you have how many replicates? Okay, you have how many replicates for each group. So if you remember, experiment design, you need to describe what is the data type, variable type, whether it's dependent or independent. If the dependent, what are the variable? So it's the size of the flower. And for the independent variable, it's a group. So you have the treatment, so 3 groups or 3 treatments, which is a red, yellow, blue color flower. Then after that, for each group, how many replicates? Okay, for each group. Okay, so for example, this one I have 10 replicates. For this one, I have 8 replicates. For this one, I have 7 replicates. Okay. So until here, is it clear? Okay. So only you have done this, then the next step is to choose the test. Choose the test you're going to use. Okay. So if this is a case, which test that you're going to use? So there's one more thing I forgot. Right? So formulate a hypothesis. At the same time, you need to set your criteria. Right? Okay, you need to set your criteria alpha when you formulate a hypothesis. You want to test is there any differences at the significant level of what? So usually we use 0.05. So there's one or two of you have asked why 0.05. I mean, what are the rules? Actually, there's no rule. They just commonly use is a 5% of the type 1 error that we're willing to commit if there's a type 1 error. So it's just a rule of thumb. Okay, it's just a rule of thumb by 0.05. Okay, so for this one, I'm going to discuss later in detail. This is a statistical significance. So next thing is to choose a test. So what test you're going to choose? You're going to use. So that's the reason why you need to learn all the tests. So you learn so many tests. So first we see, okay, so this is a question about difference, correct? So for differences, what we have the one sample test for the differences, two sample tests, three more than two sample tests, correct? Okay. So this is the differences. So in this case, we have more than two samples. So 1, 2, 3. So in this case, you're going to use two sample tests. Okay. So the test you're going to use is, more than two sample tests. Okay. So this is the first decision that we made. And for the more than two sample tests, we know that there are different type of more than two sample tests. Is it one factor or more than one factor? Okay. So one factor, for example, one-way ANOVA. So two factor, more than one factor can be two-way ANOVA, two factor, three factor, and so on. So in this case, how many factors that we have in this example? Only one factor, because you only have one factor. The factor is color. And then for this factor, we have three different groups. Okay. This one clear? So we only use one factor. So we're going to use one factor more than two sample tests. Okay. Then for one factor more than two sample tests, so what are the tests that are available that we can use? So you can choose either one-way ANOVA or what? The non-parametric test. Kuka virus, okay? The non-parametric test. Okay. So now we know that we're going to use this or this, okay? But before we have the data, we cannot decide because one-way ANOVA, they have their assumption, right? Okay. For example, the normality, okay, and also the homogeneity of variance. Okay. So that's the reason why in your project one or in your proposal, you need to mention in your data analysis, okay? Explain in detail what is your experiment design, what is your objective, what is your statistical hypothesis, and what are the tests that you're going to use, okay? So in this case, I will say I'm going to use this or this, depend on the assumption test. If the normality test or the homogeneity of variance test show that the data is not normally distributed or it's not, the variance is not equal between samples or both of them, then I'm going to use the Kuka virus test. Okay. If the data shown that it's normally distributed and the variance between groups, okay, is the same, then I will use the ANOVA test. Okay, right? So actually, this is the most important thing before even you perform the test. Okay? So you already know what are the test candidate tests you're going to use for your research. Okay? There's no such thing that you try and error. Right? It's not like you collect the data, then after that you just try all the tests and see which one can be used. It's not done in that way. That is wrong. Okay? If you want to use the statistical test, you need to follow this procedure. So as you can see, it's not about the software like SPSS or R. Okay, it's more on the experiment design. If you can design it properly, if you can explain this in detail, then I'm pretty sure you will know what test you're going to use. Okay, in most cases, sometimes to when you conduct your after you conduct your research in your FYB, or for example when you do your master, most of the time that the student collect the data, only then that they go to ask their friends or lecturers and ask which test I can use for my data. If you ask this question, that means that you don't understand at all what you have been done. Okay, you have been doing all the time. Okay, so this is very important. So far, any question about this?
Doctor,
Mm.
if 1 out of 3 samples didn't follow the normal distribution, is it considered as violated the assumptions for ANOVA?
Yes, yes.
Oh.
So again, if you read the textbook, they will say that actually the assumption is just an assumption, just a guideline for you. So it doesn't mean that if your assumption, if you do not fulfill the assumption, you cannot use the test at all. Doesn't mean that. It's just that if your data violate the assumption, okay, then you still can use ANOVA, for example. Let's say, for example, I can give it's a good question. So let's say, for example, now I run the normality test, right? For this sample, it's okay, normal. For this sample, it's normal. For this one, it's not normal. Okay, but the variance between groups is the same. So actually, I violate one of the assumption, right? So in this case, what I will do is I will still run the ANOVA, but I will interpret the result carefully. Okay. If you read the textbook, if you reopen the textbook, they will say that most of the statistical tests, they are quite robust enough. Okay, they use this word. So that means that, yeah, this test, they have the assumption, but actually if you violate a bit of the assumption, it's still okay. It's still not too bad. Okay. So if in that situation, but in your case, I will say that I will just run the parametric and non-parametric test. If both tests show me the same result, that means that both of them reject the hypothesis, then I will go for the parametric test. Okay, if my data violate one of the assumptions, if the both tests, the parametric and non-parametric test, give me the different conclusion. One say reject, another one say does not reject. Then in this case, then maybe I will stick to the non-parametric test. Okay, because I already violate the assumption of the parametric test, right? Okay, if both give you the same conclusion, but that means it doesn't really matter. And this one actually there's no regulation and say how much you have violated the assumption, then you need to use parametric test. No, it's just some guideline. So the assumption just like a guideline. Okay.
That means we have to run both tests before, and then include both results.
Yes. Yeah, you can do that as well. But so let's say there's no harm to run both tests, right? Correct. Because both of them have the same objective. Correct. So the reason you want to run both tests because you have violated the assumption. Okay. And then if I violate the assumption, I still run both tests. If both tests show me the same conclusion, then that means that it doesn't matter which test I will use. Correct? They give me the same conclusion, reject or not to reject the hypothesis. If the conclusion is different, okay, and my data is violate the assumption, then I will go for the non-parametric test. I will follow the conclusion that provided by the non-parametric test. Is this clear?
Yeah.
Okay.
Okay. Thank you.
Then the rest is just quite straightforward. So if you know how to run if you have the data, you test for normality, then you can run for both tests if you want. If your data is normal, then I will just go for the parametric test. There's no point I go for the non-parametric test, correct? Then after that, I run the test, I get the test statistic. I can get the conclusion. Okay. At the same time, I need to know how to report the result. So that's the reason why in your last tutorial or assignment, you're going to learn how to write the report. And then you're going to learn how to report the result in a written form. Okay, so there's a different test that require you to write in a slightly different way. Okay, so for example, if this is an ANOVA test, in the report, I'm going to say that, okay, I need to report what is the F value, okay, what is the degree of freedom, V1, V2, and what is the P value. So these are the things I need to include in my result section. Okay, so the P value, if this is smaller than 0.05, then in my conclusion, I will say I'm going to reject the null hypothesis. I'm going to reject this one and take this one. Okay. So this is what I'm going to test you for your final test. So there are 5 tests which I'm going to test you. Okay, going to give you a scenario. So the question, the objective might be really wrong, or maybe you need to change a bit. Okay? And of course, the data I will give you. So to help you to do this. For the rest, you have to do it yourself to test whether you really understand how to apply everything that you learn. Because until now, only about 20 of you, 25 of you have completed all the tutorial assignments. So most of you who are watching this now, maybe you speak confused, but it's okay, don't worry. Just to try to catch up a bit, finish all the tutorial assignment. Then after that, we're going to have a few of this exercise for you. Is it okay? So this is the most important lecture for today. So any questions so far? We only have 2 more things to discuss. After that, we end the class. If you don't have any additional questions. So the next thing that we're going to discuss about is about your test, your final test. Okay, your final exam or final test. I explained a bit last week, but maybe I explain a bit more later. And also about the R, a lot of you have questions about the R. And the last thing is about the P value, why 0.05. So maybe we discuss briefly. So these 3 topics, very small topic. We need to spend about 5 to 10 minutes for each one. So any questions for those things that we discussed earlier? No, right? Let me check the Facebook if there are any questions. For those who watch from the Facebook, do you have any question? If you have any question, just write in the comment here. So there's a question from Darren. He asked earlier. So just now, the example that I give is that for different group, I have different replicates, correct? Okay. So for this one, so for this one, it doesn't really necessary that for each group you need to have the same number of the. Doesn't really matter. Okay, it doesn't really matter. But when we design the experiment, of course, we will, if possible, we want to make sure we have the equal number of replicates for different groups. So this is when we design our experiment. But in reality, sometimes, even though we design, we need to have 10 flower for red, 10 for yellow, 10 for blue, correct? So this is what we read in the proposal. But in the reality, when we go to the field, we found out that it's very difficult to get 10 blue color flower, for example. In that case, of course, you don't have enough 10. You only have 8, 7, or something like that. So if there's a case, it's still okay. It doesn't really matter. Okay? So the replicates for every group can be different. Not necessarily need to be same. Okay? Unless there's a test that in the assumption they say that you must have the same number. If not, then it should be okay. Just check the assumption for the test. Okay? For the ANOVA, I don't think it's require you to have the same number of certificate for different groups. Okay, right, Darren? So the next thing that we need to discuss about your test. Okay. So for your test, a lot of you ask the question, you want to learn more about the test. But I think at this point of time, it's better that for those who have not complete your tutorial assignment, better focus on your tutorial assignment first. Because if not, then if I explain what you need to do in your final test, you still a bit blur because you have not done all the tutorial assignment yet. You don't understand what I mean. Okay. So just complete all your tutorial assignment. Try to do it as soon as possible. It's not going to take you a lot of time. Okay, you need to spend about 2-3 hours a week. You should finish the tutorial and so the lecture for 1 week. Okay, and let's say I'm thinking to have a tutorial session only for those who have complete all the tutorial assignment. So that means that for those students who are ready for the final test. Okay, do you think it's a good idea to do that? So I'm going to, since all of you already in one separate WhatsApp group, so there are about 26 or 27 of you. So we're going to have we're going to discuss with you in the WhatsApp group whether we're going to have a 1 or 2 sessions of the tutorial just to prepare you for your final test. Okay, so this one we're going to discuss later in the WhatsApp group. And for the rest, it's better that you focus on your assignment and tutorial. But I will still let you know when I'm going to have a tutorial for that group of students who are ready. Just in case if you want to join, you still can join, but it's up to you. So this one clear? Is any question about this? Okay, should be okay. So for those tutorials should be quite short because it's very focused, just to prepare you for your final exam. Okay, not to discuss the topic in detail. Okay, right? So there's one question from Darwin. Darwin. Yeah. I think you can see my screen, right? So Darwin asked, so this is from the last example. So the null hypothesis will be there is no effect of color on the size of flower. No mean difference in the color and size of flower. So the correct one should be this one. But you should not write in this form. So this, when you write the null hypothesis, usually we will write for the parametric way. Okay. So the way that you write is for the non-parametric test. So this one, this is for non-parametric test. So this is a hypothesis, okay, that you write just now, right? So of course this can be your null hypothesis, of course. Okay, then the alternative is the opposite. Okay, there is an something like this, huh? But you have to remember, this is the way when you write for the non-parametric test. Okay, because in the non-parametric you don't use the mean and variance, right? So that's the reason why in your statistical hypothesis you cannot put this symbol. You cannot put the mean. Okay, you cannot put the mean. However, usually when in your proposal we will write the statistical hypothesis in a parametric manner. So it should be something like this. So this one clear, right? So for those who submit your non-parametric tutorial and you write the, if you write the hypothesis in this way, then it's wrong. Eh? For non-parametric test, you have to write your hypothesis in this way. This is a non-parametric test. This one clear, right? Okay, it's a good question. So let me check if there are any other questions. Okay, right? Karin? Calvin? So, it's one clear. The next question is about the R. So, in your Google form, a lot of you say that you have some problem about the R and things like that. Okay. So, as I mentioned earlier, the R is just a tool. So, the reason I introduced R to you because the R will be the most useful data analysis tool for you to use in the future. So, the R not only can be used for the statistical test, it also can be used for different type of data analysis. Okay, you can do the genetic analysis, you can do the GIS analysis, you can do all sorts of analysis by using the R. So it's very important you learn the R. And the R is an open tool, so you can easily find the solution. So most of the time, if you have an error message, what you need to do is just copy the error message, paste in the Google, and then you will find the solution most of the time. Okay. So you just need to live with that one for R. Okay. So there are some other software available, of course, like SPSS, and there is another software which is very useful. If you have time, maybe I share with you just for your information, but not now. For now, we're just focusing on R. Now. So any questions about R you want to ask? No. Okay. So the last thing that we want to discuss a bit is it's just a follow-up for what we discussed. So why alpha is 0.05? Okay, why alpha is 0.05? Can you see my screen now? No. Can you see my screen of the previous example? Never mind. So just now we said the alpha is 0.05, right? Why 0.05? So for this one, you can Google a bit. So the one thing that I want to mention is that when this is not the truth, this is not the truth. This is just a criteria that we use to make a decision whether we not to reject the null hypothesis. Okay, whether we use this to reject or not to reject the null hypothesis. Okay, this is not the rule. So if your p value is smaller and your alpha they say is 0.05 and your p value is smaller than 0.05, you reject the null hypothesis, right? So if you use the example just now, if our null hypothesis is this one, okay, then if you reject this, then we will say that there's a difference. Okay, there's a difference. Okay, there's a difference. Then we will reject the null hypothesis, then we will say that there's a difference, correct? So the difference is a statistical difference. So there is a clear statistical difference. Okay, statistical difference, okay, between the size, between the different color, okay, the flower in terms of their size. Okay, but it is sometimes statistical significant, okay, difference. It doesn't mean that it's not equal to biological significance, biological difference. So it doesn't mean that the difference is significant from the biological point of view. Just from a statistical point of view, when you do the measurement, it's different, statistically different. Okay, statistically different, but it's not necessarily biologically different. The difference is biologically significant. Maybe the sign is different, but it doesn't mean a lot from the biology point of view. Okay, so this is the one thing that you have to remember. Okay, one thing that you have to remember. So the p-value is just a guideline, it's just one of the statistical approach. It's just a tool. If you use other approach like the Bayesian that I told you, actually they don't use the p-value at all. Okay? They use other approach to make the decision, whether to reject or not to reject the null hypothesis, or what is the likelihood the null hypothesis is correct to the alternative hypothesis, for example. Not the black and white. It maybe give you more information for other type of the statistical. So this is the thing that you have to remember. Statistical significance doesn't mean biologically significant. Okay. So I think that's all for today. Do you have any other questions? Do you have any other question you want to ask? So just a recap. So today we discussed about, so I give you some, I make an announcement just now. So remember to fill out your attendance form every week, regardless whether you're going to attend or not to attend. Just take you 1 or 2 minutes to fill out the form so I can make some preparation. Okay. At the same time, try to follow, for those who have not complete the week 9 and 10 and tutorials. So try to complete the tutorial as soon as possible so that you have more time to prepare for your final test. Okay, so you have more time to try to understand everything in rather than just catch up week by week. So hopefully you have a few weeks to prepare for your final test because you need to understand everything before you can sit for your final test. Also, we discuss about the importance of experiment design. Okay, not only about the t-test, ANOVA, how to design experiment, how to apply the statistical analysis in your research. So there are many things you need to do. And then we also discuss a bit about the R, about the P. Okay, the statistical significance doesn't mean biologically significant. And also, I'm going to discuss with those students who have completed their assignment. So they complete all the tutorial assignment in the WhatsApp group to find a time to have a short tutorial to prepare you for the final exam. So this one is optional for those who have not completed a tutorial. So because I'm going to make a lot of this session, so no worry, you're going to join the later session to find a time to have a short tutorial. So that's all that I will discuss for today. So any question? Last?
No.
So if no, then I will just let you go. So that's all for today. So thank you very much. So I will see you next week.
Okay, doctor.
Good, doctor.
Okay, bye.